Welcome to DeepEX. In this example, we will create and analyze a model of a Deadman Sheet pile wall. In this project file, we will create two different models of a Deadman Sheet pile wall. So we will create here two different design sections. In the first one, we will create the model manually. And I will also right-click here and I will add a new section. And in this design section, we will later create the model using the model wizard. So we access first the first design section, and here on the model area we will create the model step by step graphically. Our first action, as always, should be to define the list of soils and define their soil properties according to the geotechnical report and create the stratigraphy for this model. Second, we will select to add the second wall to the model, so I will press this option in order to add a right wall. So a right opposite wall will be added here and we will modify its properties later. We will access the structural sections. We will press on the option wall sections, and in this dialog we can actually create as many wall sections as we wish. I will add two sections. The first one will be the front sheet pile wall, and we will select here the sheet pile wall option and we will change the structural section to something different. Let's use AZ19 for this one. And I will access new wall 1, and here I will define a soldier pile lagging wall in order to simulate the section for the back Deadman wall. So I access the soldier pile and lagging wall sections and I will choose a soldier pile and lagging wall with I-beams. Here I will select the I-beam section. Let's use something like HP16 in this one. I will use this HP1688. I will define the horizontal spacing between the I-beams at 8 feet. And I will place the lagging inside the flange. So this should be the structural section for our wall. Now that we created the two wall sections, I will access the left wall, which in this case will be the back Deadman wall, and from the drop down I will use the new wall 1 section, which will be my soldier piles. I will define the back wall depth to be at 25 feet, and I will access the front wall, which will be the sheet pile wall. I will define its initial depth to be at 45 feet, and we can later optimize this. And I will define the X wall coordinate, which is actually the top left point of the wall, to be at X coordinate 60. I will add the construction stage, and in this new construction stage I will choose to excavate 5 feet below the elevation where I wish to add my tie rod. So I go here and on the left side I will excavate to -5, and at the center between the two walls in stage 1 I will excavate to -5 also. I will right click here and add another stage, and in this new stage I will install my tie rod. I access the draw supports option and I select the tool to draw a ground anchor. I click first on the left wall and next on the right, and in the dialog that appears I will define the exact elevation of the tie rod, let's say -4 feet, and the horizontal spacing between the tie rods. Also we can select and define the structural section for our tieback sections. Let's leave these 4 strands. I press OK, so the support is added. I click and I add a new stage here, and in this new stage 3 I will backfill on the left and at the center, and at the same time I will excavate to the right. So I will excavate to -20. I will go now to the draw loads options and I will select to add a strip surcharge, and I will add a surcharge here. So I click on 2 random spots on the surface, and in the dialog that appears I can define the exact position, X coordinate, where the load starts and where it ends, and the load magnitude. So I will place it from x coordinate 10 until x coordinate 55, and I will use a 0.6 KSF load. Now I will go to the Analysis tab where we can set our analysis settings. First of all, we can select the analysis method. In this one we will use the classical limit equilibrium analysis. If we wish to assign any geotechnical standards, we can do it from here. We can select a design code, analyze a code case, and we can select any design standard and any load combination from this standard. In this example, I will not use a standard. I will keep the simplified flow analysis for my water pressures, else I could turn to hydrostatic or perform a full flow net analysis. And I will go here in the last stage and I will select to change the drive pressures to be FHWA apparent pressures. So in the first stages it will use active pressures, and in the last stage it will use FHWA apparent pressures. I will access now my second design section, which opened in a different tab here, wizard. I'll go in the general tab and I will open the model wizard. Here we will choose our unit system. We will use English units in this one also. I press OK. I select the analysis method to be the limit equilibrium, and I select the classical earth pressures to be FHWA apparent pressures from the stage where at least one support level is installed. Also, I will leave the selection as it is, so it will use simplified flow for the water pressures. In the second tab, I can select my project type. In this one, I will choose the Deadman wall. Here we can define the final excavation depth, so I will put it 20 feet. I will define the back wall depth, and it will be 25 feet. This is the distance between the two walls. Let's place it 60 feet. The groundwater elevation I will leave to -24. The front wall, it will be 45 feet. The initial ground elevation is actually elevation of the first stage where we supposed to have done the first excavation. So I will put it at -5, and depth to the tie rod I will say 4. I will leave the same structural section, 4 strands. I will not change the soil properties and the stratigraphy, it is already defined in this example. We will access later and assign each wall section to each wall on the model area. And for the surcharges, I will choose to add a strip load 0.6 KSF developed for 20 feet, starting 5 feet behind the wall or 2 feet behind the wall. Next, I will keep the current structure and geotechnical codes. So now the model is created from the model wizard here automatically. If I open both models, I will see that they are similar. Here we have the initial excavation at -5, we have the tie rod installation, we have the backfill, and we have the excavation. This is the model as it is created from the wizard. And this is the model that we created manually, the excavation, tie rod installation, and I used in the same stage the backfill operation on the left and the excavation on the right. When I run the analysis, according to the limit equilibrium method, I can see the analyzed results, the most critical results from every construction stage, the maximum wall moments, wall shears, the structural wall ratios, moment and shear. So I see that the wall is pretty much fine. I see that the support fails structurally and geotechnically, so I need to do something to increase my support capacities in order to optimize this model. And I see that the wall embedment safety factors are okay. I need all of them to be above 1.5 for us to be safe. And if we close, we can see the results graphically in every construction stage. Here I can see the wall moment diagram, the moment capacity and the displacements for every stage. I can open the wall shear with the shear capacity for every stage. We can see the soil pressures again for every construction stage. We can see the support reactions. We can see the net horizontal pressures, etc. So based on these results, we can take a decision what to do and how to optimize our model. One parameter that is important for the Deadman walls is that the passive pressures on the back wall, a part of them is transferred as an impact load on the front wall, and this has to do with the distance between the two walls. This sometimes causes the front wall to fail, this additional load that comes from the passive pressures of the back wall. In that case, we need to reconsider the distance between the two walls, we need to consider to increase this distance perhaps, and inside the software, in the analysis tab, in the resisting side pressures, we have an option adjust impact load for Deadman walls. If we access this option, in the dialog that appears, we can adjust a factor that is adjusting the impact loads, the loads that are transferred from the back wall and act on the front wall as active loads. Visit our websites in order to review more information about our software programs and services. If you wish to book a free online presentation with one of our experts, feel free to contact us. Thank you for watching this video.